In this video, we're going to learn how to solve a system of equations by using substitution. Now, substitution is best used when one of your variables has no coefficient or a coefficient of 1 in front of it, as in the following example. So what we see here is that in this particular system, we actually have two variables with a 1 as a coefficient. We have the y in the first equation, and we have the x in the second equation. This makes this a perfect type of example to use substitution for. So let's take a look at our steps. So the first step says to choose a variable from either equation to isolate. Pick whichever is easiest. So as we can see in the example, either the x or the y can be isolated. It doesn't matter which one you choose, but pick one and be consistent. So we're going to do that first. We are going to take, let's say, I'm just going to use the first equation. We're going to isolate the y by subtracting the 3x from both sides. So we get y is equal to negative 3x plus 5. That's step one. And again, we could have worked with the second equation and gotten the x by itself by adding the 2y to both sides. In the next step, we're going to take what it equals and we're going to circle it. And it may sound like a silly thing to do, but I think it works. We're going to circle it here. And we're going to replace that same variable in the other equation. So here we go. We're going to draw this little arrow here to indicate that we're going to replace the y in the other equation with the negative 3x plus 5. Now, it's important when you do this, I'm going to do this right now, that you make sure to include parentheses when you rewrite your equation. As you can see, the parentheses are going to be important so that we make sure that we know to distribute the negative 2 to the negative 3x and to the positive 5 as well. At this point now, you should only have one equation with one variable. As you can see, by substituting, the y has disappeared and we're only dealing with x's. So we're going to go ahead and solve it. And in order to solve, we need to go ahead and we need to distribute this negative 2. So we get x plus 6x minus 10 is equal to 4. We combine like terms. We get 7x minus 10 is equal to 4. Add the 10 to both sides. 7x is equal to 14, and so x is equal to 2. Great. So far, we have one part of the equation, one part of our solution that we need. We have our x, but we're not done because we know that a solution to a system of equations is both an x and a y, and so we now need to go ahead and find y. The next thing we need to do is we need to take what we found, which is x equals 2, and we need to plug it into either of these original equations in order to find y. And I'm going to work with this equation here, the second one. So if we have x minus 2y is equal to 4, we get 2 minus 2y is equal to 4. So negative 2y, we subtract the 2, is equal to 2. And so y is equal to negative 1. And we are almost done. And the last step says write your answer as x comma y. And so we're going to write our answer as 2 comma negative 1. Make sure that you put your x first and your y second. You want to make sure you don't put them backwards. And the reason we want to write our answer as a coordinate is because it helps us further understand that these two original equations that we have are both linear equations. They graph a line, and this point here is exactly their point of intersection, which means that if, in theory, we were just to sketch this out, here's my 2 comma negative 1. This is the point. I don't know what these lines look like, but whatever these lines are, they're going to intersect exactly at this point.